on your presentation day, you will bring to me your rubric. Well, no, I already have your rubric. You're going to bring to me your printed out copy of your final report and your research plan. You'll give it to me. You'll hook up your Chromebook over here, same way I have my computer hooked up, and you will begin your presentation. My name is Mr. Limbaugh, and this is my science fair project. My research question is, does water conduct electricity? And there's a couple reasons why I chose this research question. One is because I've watched several movies where it was like all scary and people were taking a bath and somebody comes in and throws an electrical appliance and they're trying to kill them. I'm like, that makes absolutely no sense to me. Because I also understand some things about water and electricity. So I think that there's a misconception that water conducts electricity. In my background research, I have found out that water does not conduct electricity because water is a covalent molecule. It doesn't have the free electrons or ions necessary to pass the electrons in a current. I got that information from the U.S. Geological Survey Society. They have this big article on their webpage. Additionally, I've even found out that scientists use low conductivity water as an insulator for electrical appliances that use large amounts of energy. They use low conductivity water up to 30 megawatts. That's equivalent to 16,000 hair dryers. See, that's how the hair dryer thing came in, because I watched a movie and they were throwing a hair dryer into the shower. It didn't make no sense to me, but that's a lot. My hypothesis, and this is where it's probably okay to turn and read your hypothesis or on an index card, that if the amount of salts in the solution increase at a given rate, then the amount of current between the probes in the water will increase at a corresponding rate. My independent variable is the amount of salts in a solution. That is the thing that I changed. What I measured, my dependent variable, is the amount of current flowing in the water. I had like two big challenges for my experimental design. Number one was making sure that in my control that I got a sample that was completely free of ions. I used distilled water, and I think that that done a good enough job. However, if that wouldn't have worked, I could have distilled the water myself to ensure that. Additionally, constructing my setup that would constantly measure the current consistently throughout the entire investigation took a little bit of time. Here's a photo. You can see that in my photo, I have a multimeter. The multimeter measures the amount of an electrical current. My power source was a 9-volt battery. Not too much, but enough of a current to get measured. And then I had to make sure that the electrons were delivered into a region where I can put a solution, and I have another picture to show that, but I also included a buzzer, because as soon as the circuit was complete, the electrons can flow, the buzzer sounded. As we look here from the side, you can see I have the probe from the multimeter pointed down, and you can barely see the two probes hanging to allow the electrons to flow between them. I have the other probe up here at the top, right next to the battery, so I can measure the current within the system. Here's my data. Chart 1 shows that distilled water had 0 current. But then as I started adding salts to a solution in increments of 0.25 moles, you can see through the top that as the amount of salt increases, the amount of current increased. This was a direct relationship. Additionally, in chart 2, I took samples from the community. I took one sample from Canton City and then several samples from Plain Township and one from Green. And what this allowed me to do was, once I sampled these unknowns, I was able to determine that they have salts in them because they were able to conduct an electrical current. My conclusion, the hypothesis, if the amounts of salts in the solution increase at a given rate, then the amount of current between the probes in the water will increase at a corresponding rate, is supported. In chart number 1, we went from a solution of 0.25 molar to 1.0 molar. The corresponding increase in current went from 14 milliamps to 17 milliamps. Next time, what I would probably do was make sure I have smaller amounts of salts, maybe like 0.05 and 0.10, and then greater amounts, because that would give me a wider range to predict unknown samples. Are there any questions? Thomas?
What is a mole?
Is the amount of atoms within a given object.